continuity. Continues on an interval. So welcome to college calculus. Our problem for today is show that the function fx equals 1 minus a square root of 1 minus x to the second power is continuous on the interval -1, 1. All right, before to find the solution to this problem, let me tell you something about what is a function. A function f is continuous on an interval if it is continuous of every number on the interval. If f is defined only in one side of an endpoint, at the endpoint to mean continuous from the right or continuous from the left. Okay, the solution. Okay, the solution, and in this case should be if -1, for instance here, less than a, let me write with red color here, less than 1, okay, then using the limit law. So we have, okay, so we have, and then the first step should be here a limit of f of x equals limit of 1 minus square root 1 minus x to the second power. All right, when in this case when x approach to a, here when x approach to a. All right, so that will be the first step. The second step, this is equals, should be equals 1 this 1 here minus limit of 1 minus square root, right? Here, yeah, this minus limit, yeah, 1 minus limit, no, here, this is the first step. Yeah, when x here, when x approach to a, here should be here square root 1, yeah, 1 minus x to the second power. Yeah, that's it. This is which law here is a law 2 and 7, law 2 and 7. So next step should be let's write 1 minus a square root, so everything is square, limit of 1 minus x to the second power when x approach to a, right? This is the law 11. By the law 11, let's write the law right here. So next step, we will have here 1 minus, so square root minus square root number 1 minus a to the second power. All right, so this is which rule is this? Is by rule 2, 7, and 9. All right, and then our conclusion is equals f of a. That's the answer. All right, but that's by addition 1 or definition 1. By definition 1, f is continuous at here at let's see, f is continuous here. F is continuous at a the if, all right, if we have a -1 less than a less than 1, all right. Similar calculation show that for instance here, if we have limit, there's a similar if limit of f of x, right, equals 1. Here in this case, when x approach to -1 to the right side, right hand, okay, right hand. So this is equals 1 equals f of -1, and it's similar to that process, and a limit here, this right limit f of x is on the other hand is equals 1 to here 1 equals f of 1 when x here x approach to positive, -1, yeah, just 1 to the left side, left hand, okay, left hand. That's it. It's another process. So it continues from the right to -1 to a -1, and continues from the left at +1. Therefore, according to definition 3, f is continuous at the point, at this point, -1, that is the problem, comma 1. All right. So this is we want to see the graph. Let's try to make the graph. So the graph is this is the formula for the graph: x to the second power plus y minus 1 to the second power equals 1. All right, this is the graph. The expression for the graph. Let me make a little graph right here to see how it looks. This is x, this is y, okay, 0, 1, -1, and 1. So the graph is running like this. So the graph is look like this. This is our graph, and then what is our problem? The problem is right here. So this is our graph. So let's write it right here. fx equals 1 minus square root 1 minus x to the second power. Right? This is our graph right here. So it looks like this. So that's it, very, very simple. So just, we are talking about the continuity, okay, continuous, when a function is continuous in one point or when it's continuous in the other point. We are using left hand and right hand, like I write it here. See, this is right hand, this is left hand. So this is very important. It's another way, but this is a very important clue to find the answer, okay? This is A, right? So thank you so much.